Alright, section 8.1, the real number line and absolute values. Let's see what you're going to be looking at. Our objective for this lesson is going to be graph real numbers on a number line, identify types of numbers, recognize the inequality symbols and use them to compare real numbers, and find the absolute value of a real number. So let's jump right in. I got some things highlighted here for us. Okay, the negative sign, which you can see there, indicates the opposite of a number as well as a negative number. It is used also, as we shall see in 8.3, to indicate subtraction. Note on your calculator the subtraction key on the right hand side and the negative key at the bottom key. Okay, they are different. They will do different things. Okay, you'll get weird. Get used to using the the negative key whenever you need to use the negative key, and the subtraction key whenever you need to use the subtraction key. So let's continue on here. Okay, we've got the set of numbers consisting of the whole numbers and their opposites. It's called integers. Okay. This little set they're giving here is just a little bit awkward. Let me just kind of fix this just a little bit here so we can kind of understand this a little bit better. This guy right here, that is not what the integer symbol looks like. Okay, this right here is called the natural numbers. Okay, I don't know why they used this symbol for that. Okay. What this symbol is, so let's go and actually, you know what, let's just go ahead and just get rid of this altogether, and I'll show you what the natural numbers look like. Okay, the natural numbers look like the set starting at 1, okay, and they go 2, 3, 4, ... and they're going to keep going on forever, okay? Then you have the set of whole numbers, okay? The set of whole numbers, well, it's going to be the same thing as the natural numbers, just add 0, and then just go 1, 2, 3, 4, and then ... Okay, and then we have integers. Okay, integers is a Z because it's like a German word. Okay, now which I don't know what exactly it says, but it means to count. Okay, but whenever we put that in a set, we can go ... -3, -2, -1, 0, 1, 2, and 3, comma ... means they go off to infinity. And when it was talking about opposites earlier, this is what I meant. Notice you have an opposite of these two. You got a 3, and then the negative symbol makes a -3. So that's what that was talking about in the previous slide. Okay, so yeah, I don't know why they did that. Hopefully that's just like a misprint or something, but still. Remember, Z is integers. Let's go to the next one. Okay. Find the opposite of each integer. Well, remember, the opposite is going to be whatever is opposite on it on a number line. So let me get my pen out here. Okay, let's draw us a number line. Now, I'll just draw us one number line here. As good as I can here. Let's put 0. Remember, on one side, you're going to have 1, 2, 3, 4, 5, 6, 7. So let's go 1, 2, 3, 4, 5, 6, 7. Well, remember over here, going in this direction, you're going to have 1, 2, 3, 4, 5, 6, 7. But all of these over here are going to be negative. So you got -1, -2, -3, -4, 5, 6, and 7. So we can say that all of these going from here back, okay, are going in the negative infinity. And all of these going this way are going to the positive infinity. Remember that little symbol there is the infinity. That just means a number that goes on forever. We can never actually equal it. So let's see here. What is the opposite of 7? Well, here is +7. Okay, well, what's the opposite of it? Well, come over here and you're going to get -7. So let's put that down. Okay, well, let's look at the 4. I won't use a highlight on this one, but we've got a -4. Okay, there he is right there. Well, what's his opposite? Well, if I go over here, 4 to here, and then go 4 more if you want to kind of see it that way, well, his opposite is going to be a 4, which we don't usually show the positive symbol, but that's what that would actually look like, okay? Positive, usually we just kind of just leave it by itself. So there's that. Let's keep going. Okay, graph each set of integers, and these are integers because notice integers can be negative and positive, but they look like whole numbers. They look like regular counting numbers, so that's what you kind of would define an integer as. So let's just kind of come in here, and instead of doing these separate, what I'll do is I'll just make one real, well, I'm probably going to have to make 2 lines here. So let's come in here, we'll graph the first one. Well, let's we'll start at 0 and we'll go 1, 2, 3, 4. 1, 2, 3, 4. Remember, I'm going to go positive to the right, always to the right, positive, okay? Positive to the right, okay? And then negative to the left, always, okay? So let's look here. We've got -1, -2, -3, -4. Then we've got 1, 2, 3, and 4. Let's start graphing these bad boys. Okay, well, we've got -3. There is that right there. How about -1? That there. A 1, and then a 3. And notice all of these are opposites of each other. Okay, I got -3 here, and then I've got, oh, did I put that in the wrong spot there? I did, didn't I? So let's put that in the right spot. There. And now I'm showing my opposites. And then I've got -1 and a 1. So all of these are opposites of each other. Let's do the next one. Draw a level line. And then we can kind of start right here. Milligan 0, 1, 2, 3, 4, 5. Over here I got -1, -2, -3, and -4. That looks like it's about as far as it goes. And literally, we're just going to drop these numbers in right onto the number line. So let's come in here. Make that a little thicker. Okay. We got him. We got the -4. We have the -2. Okay. We can go to the -1. There's a 0. And there's a 2. And in these, notice the only opposites are going to be the -2 and the +2. Everything else is not an opposite of each other. Okay. Next one. All right, rational numbers. Okay, a rational number is a number that can be written in the form A over B, where A and B are integers, and B cannot equal 0. And then that little equation with a line going through is not equal to. Okay, or a rational number is a number that can be written in decimal form as a terminator decimal. Okay, let's give some examples here. Very simple thing, very mathy words, but that's okay. Rational number is also a fraction. Okay, we should know that. You're also going to know it by, it's got its own little symbol. Okay, they're going to be a Q. And rational numbers can be, well, a rational number can be a whole number. Okay, you could have a -2. Okay, because remember, I can put -2 over 1. You could have just 1. You can have 1/2. Now these are not going to be in order, obviously. You could have 0.3 and so on. Okay, and that's what that means here. When you see terminating decimal, that's going to be that guy right there. It stops at a certain point. Okay, also notice how this decimal here can also be turned back into a fraction. It can come in here and we can make it 3/10. Okay, that's the basic definition of a rational number. Okay, and we're going to see plenty of those. Those are just going to be numbers you're just going to want to learn. Continuing on, okay, list the numbers in the set S that are whole numbers. Okay, integers, rational numbers, and real numbers. Okay, whole numbers, remember, they start at 0. Okay, and they can go on from there. So let's look over here. Let me get my pen out. Well, whole numbers, okay, and I'm not going to be able to just write the whole thing, but remember, they kind of look like 0, 1, 2, 3, ... Okay, well, let's look through here. Well, 5 doesn't. That's not negative. That doesn't look like one of those. 0, there's a 0, so I can have a 0 as a whole number. Square root of 2 does not look like one of those. And if I take the square root of 2, I get a really nasty number. And then we have 17. So that works out there. Okay, what about the next ones? Let's keep on looking through these. Okay, how about the -5? Okay, the -5, well, let's remember that integers, okay, they can go from like ... to -5 to -4, and then I'm going to put a little ... They can go from 0, 1, 2. They just keep going forever. Negative and positive, they look like whole numbers, but they have opposites. So let's look through here. Well, I've got a -5 again. I've got -5 there, so I can have that. Okay, how about the 3/4? Well, those don't look like fractions. Okay, so can't have that. Okay, how about 0? I can have 0. Okay, because notice you can have integers and whole numbers because look, there is a section in there that they look the same. You would call these subsets. Okay, so whole numbers are a subset of the integers. Okay, rational, sorry, integers still coming with that. And then we've also got the 17 there as well. Okay, because look, the 17 still kind of matches what I got going on here. Well, rationals. Remember, rationals can look like fractions. Okay, or decimals. Okay, oops, that can be turned easily into fractions. Okay, that's how I always remembered it. So looking through it, well, remember -5, that's going to be a rational because I can write that as -5 over 1. Okay, well, 3/4, that is an obvious fraction. 0, I can write that as a fraction because I can put that over 1. So you're noticing all whole numbers and all integers are also going to be rational numbers because the integers are a subset of the rational numbers. Okay, so we can kind of keep going through here. And I got 0. Well, that square root of 2 still got me a little bit weird, so I'm not going to put that down yet. And then I've got 17. Okay, and then let's see here. Real numbers. Well, all of these are all real numbers, so all the numbers are real numbers. So we were able to classify almost every single one of our numbers here, except for this guy, but we're going to learn about him, so don't worry. Okay, graph the set of real numbers. It's supposed to be another graphing problem, so we can just kind of come in here, just grab our pen, simple graph, just draw that. Got 0, 1, 2, 3, 4. Remember your negatives go to the left. -1, -2, -3 was my largest number. It looks don't have to go that far. Okay, let's look at this -3/4. Remember, 3/4 is the same thing as saying 0 of, this would be a negative, so it'd be negative 0.75. Okay, that'd be that guy. Well, let's go to the negative direction and see that -3/4 would probably be right about here. Okay, so we can put -3/4. Well, 0, that's pretty obvious. That's a nice one. Okay, so 0's there. 1, that one's pretty easy. That's there. 1.5, remember 0.5 is this little 0.5 equals 1/2. So we know where the 1/2 is. We're just going to go right here and go to 1/2. And then we've got 3, and it goes to right there. Straightforward and simple. Don't make it hard on yourself. Just kind of match up the numbers where they're supposed to go. Alrighty, continuing on. Alrighty, reading from left to right on this, okay? I would also like to say on this one, if I had to say things, read from the variable, okay? Like I said, this should all be kind of review for us right now. But like if I said like this, x is equal to 1, well, that's how you read it. But I could also put this, now, if I wrote it this way, okay, you could say 1 is equal to x, or I could also still read this as x is equal to 1. Well, let's look at the next one. X is less than 1, okay? That sounds fine. But I could also put it this way, 1, okay? Notice if I flip this, that says the same thing, okay? So reading from the decimal makes a little bit more sense. I mean, reading from the variable makes a little bit more sense. X is less than 1. Okay, so that's how come I say read from the decimal. So let's go over here to the next one. Determine whether each statement is true or false. Okay, we're just going to write a T or an F here. Okay, 7. Okay, we're going to read left to right. Notice we don't have variables. Okay, so I'll put it down here. No variables. Read left to right. Okay, just like you normally would. Okay, so I have 7 less than 15. Yeah, that is true. 7 is less than 15, so that's true. Let's go and put that down. True. How about 3 is greater than negative 1? Well, let's look at this. We got a number line here. My 3 is going to be way over here, and then negative 1 is going to be right here. So yes, that sounds very good. Well, is negative 1/2 less than or equal to 1/4? Well, let's think about that one. Okay, we could always graph it out if we wanted to. Okay, but if we do that, what are we going to get? Okay, well, let's look here. Let's graph this. Okay, let's put a 0 here. Okay, and let's put a negative 1 here. Fractions tend to mess with people just a little bit. Okay, so it's saying negative 1/2 is less than negative 1/4. Well, my 1/2 is going to be right here, negative 1/2. Well, then my negative 1/4 is going to be right here. And remember, when we go in the negative direction, when we're going in this direction, the further over you get, the smaller the number is. So when this is saying negative 1/2 is less than or equal to negative 1/4, that is true. Okay. Let's go to the next one here. We got 2.7 is greater than or equal to, that little line there is or equal to 2.7. Well, 2.7 is not greater than 2.7, but it is equal to 2.7, so that would also be a true. And then we have negative 5 is greater than negative 6. Okay, well, once again, let's look at our number line here, and we have 0 here, and let's go ahead and put our negative 5 and negative 6. Well, notice the negative 6 is further away from 0 going in the negative direction, so that means it's less. And this is saying that the negative 5 is larger, so that would actually be false. Negative 5 is not larger. Okay? Think of it this way. I owe less money if I owe you $5 than I owe you 6. Okay? I owe more. Okay? So that's kind of how that works out. Well, let's continue. Absolute value of a real number is its distance from 0 on a number line. Note that the absolute value of a real number is never negative. Okay, let's just kind of do some of these really quick here. Okay, just kind of kept these as their solutions. So look here, we've got 6.3. Well, the absolute value of 6.3 is 6.3. Let's kind of see why here. If we drew a number line here, and I had 0 right here, and 6.3 right here, the distance from here to here is 6.3. Because remember, this is going with distance. Okay, that's why it's never negative. So that's how come this is 6.3. Well, 5.1, negative 5.1, the absolute value of that is 5.1. Well, that is because, okay, it doesn't matter about direction. Okay, we're looking at distance. If I have a 0 here and a negative 5.1 here, well, the distance from here to here is positive. Okay, distance, always positive. Okay, well, let's go here and let's see the last one here. Okay, true or false? The absolute value of negative 4 is greater than or equal to 4. Well, let's think about this for a second. Absolute value of 4. What is that going to equal? Well, let's think about it. If I drew a number line, okay, put a 0 here, I'm going to negative 4, so I'll go 1, 2, 3, 4, and there's my negative 4. Well, I'm going a direction, okay, of negative 4 to negative 4, but my distance from 0 to 4 is 4, so that actually equals 4. Well, this is read as greater than or equal to 4. Well, greater than 4, that doesn't make any sense. 4 cannot be greater than itself. But that little equal sign there, that makes this whole statement true. That's how I want you to do these. Just kind of piece these out. Talk yourself through them, okay? And it makes more sense. Okay. If the absolute value of x is 7, what are the possible values for x? Okay. Well, let's look at this. Okay, what are the possible values for 7? Well, x can be two things. Okay, x in here. Because let's remember, if I draw a number line here, How do I get that 7 right there? Well, I can get it two ways. If I'm here at 0, could I not walk a distance to positive 7? Or could I also walk a distance to negative 7? Okay, I can go here from X, or sorry, go there from 0 or go there from 0. Both of these are a distance, okay, a distance of 7. Here is a distance of 7. Okay, so X here can either be this guy or this guy. So X can equal negative 7 or 7, and we're still just going to get this distance here of 7. And let's do one more here. If X is negative 3, what are the possible values of X? Well, once again, let's think this out, and this is going to become very apparent to you really quick once I show you. Sorry, wrong pen there. Okay, draw a number line here, and I've got 0, and then what can X be? I've got a 3 here, I've got a negative 3, and I got a positive 3 just like the last one. But wait a minute, hold on, let's stop. Negative 3. Well, how can I have negative distance? Okay, that's a good little question to ask. Okay, how can I have negative distance? Okay, because if you think about it, I can't go to the Hobbs and to the Texas-New Mexico border, and then if I come back to my starting place, all of a sudden it negated all that time I traveled. That'd be sweet if things would happen that way, but that's not how it works. I still traveled so far to the border, then I came so far back. So no, there's still a distance involved. Even if I go straight from here, okay, back to here, there's still distance involved. So right here, this is no solution. Cannot happen. Okay, you cannot have negatives. Alrighty. And there we go. We finished up this little lesson, and then we'll do some Hawks examples and just get into that.